think we're in good shape. So I'm going to get started. It's just not playing it back. Okay, ladies and gentlemen. So yesterday we talked about the relationship on the one hand between Java and on the other AnyLogic. And we noted that Java underlies AnyLogic. AnyLogic is built atop of Java. We discussed that AnyLogic turns your models into Java. And in fact, I alluded to, and perhaps after today you have a clearer idea, that when you're building models in AnyLogic, there's many little bits of Java that you write. And in that model that we were building today, there were many particular pieces of it where we wrote little bits of Java code. I'm going to actually call that model up from this afternoon because it has some illustrative pieces that I would like to be able to share here, okay? So I'm going to load in the smoking and heart disease model. And maybe you could see, where did we put Java code into the model? Give me a few examples of places we included Java code.
What's the URL?
So you go to attorney.com/ABM Bootcamp 2016 materials. That will point to the materials. And then you, from there, go into models built-in class. Okay? So can anyone say, where would I look for some Java code? Here. So here's a little model. Where would I look for some Java code? Good, in the population. And where would I look in I'm going to population here. Where would it be? I can already see several pieces of Java code. Can you point them out? Yeah, that's right there. The birth time, the statistics. Those are all great examples of Java code. Okay? We had people also having initial locations. This is bits of Java code, right? The immigration event, when immigration occurred, we had it occurring at a certain rate per year. This is Java code, and here's some more Java code. So with Java code, lots of places. What do we have Java code? Yeah, we have them in the functions for sure. We had these current age. This is Java code here. This return stuff. This hazard rate is given according to Java code, and we had Java code for the entry actions for each of these. Do you remember those? Okay, so Java code is all around once we start looking for it. Today, I want to talk about certain features of it. I want to talk about the use of this. I want to talk about what's this relationship between person as a whole and a particular person in the model, like a person referred to with this, okay? Or a person referred to using self dot when setting the parameters. So what's a class? A class is like this class, an example here would be person. That's like a mold. And it defines personhood or personness. And we can create what are called objects of that class or instances of that class. We instantiate the class to create particular people. So there's kind of personhood, and then there's particular instances, particular cases of personhood. This person, that person, that person. So here's the class, person, and this defines sort of behavior and properties of a person. And then when we actually run it at runtime, we will see many instances of that class, okay? Those are instances of that class that each are associated with a specific person. And in general, we call those objects. AnyLogic runs atop Java, and Java is what's called an object-oriented programming language, so it rests on objects, it's sort of objects. And people here is an object of class person, okay? And they share certain broad features with their properties, what sort of behaviors they can have, but they will differ in their specifics. For example, what state they're in right now, or what their birth time is, okay? Okay, let's continue to talk about this. So we define generally a class, like a person. We defined it when we're building the model, or what's called development time, and then we create many instances of it at what's called runtime, when we run the model. Okay. So here we're specifying the model, what we want the model to look like when we're building it, and then when we run it, we're actually simulating it out. Okay, I'm picking through things here. We talked about this yesterday, but suffice it to say that one class can can produce many particular instances. We can have person, and we could produce 10 people, or 100 people, 1,000 people, 10,000 people, etc. From that, just like with a cookie cutter, we can create many particular cookies, and they all share certain features. They all look like Santa Claus or something, but that's because the mold looks like that. But they differ in their particulars. Okay, how burnt they are, or what have you. Okay, so there's many familiar classes in AnyLogic. Person is a class. It turns out main is a class. There's only one main for all the experiments we've been running. Later, we're going to see that a given experiment might create many instances of main. For example, maybe it's running a sensitivity analysis, and it's going to have 4 mains loaded at the same time. So it will be running the model 4 times. At the same time, it'll be running 4 instances of it. And it'll be controlling the different mains associated, the different objects of class main, the different instances of class main. So that's a type of class as well. Simulation is also a class here. Okay, we can have in principle more than one instance, although that's what we call a singleton. We're only going to really typically have one. Now, what do we do with these objects? Well, we can read data from them, we can set data, we can call methods. That's like that function we could call, and we can create new ones. And we saw how to do that, right? We saw how to add someone to the population, or how to get rid of them by removing them from the populations. Now, there's a lot of things that we can do with these agents. And in Java, we have a lot of options. So, for example, we can connect agents together. We can disconnect them. We can ask an agent, tell me the other agents that are connected to you. We can ask for their name of that agent, and we can ask to get its connections. Okay, so there's lots of things that we can do. For example, this person, we can ask for its age, right? But that's because we've provided it. But there's a whole lot of things we can ask it to do that it knows how to do without us having to tell it. And that's because as an agent, it knows how to do a lot of things itself. And then we layer these atop of it. So to give an example, and you might want to do this, here in person, we have this little circle. We could go down to advanced. This is an extremely useful thing. We did it this morning. I'll do it again because this morning's videos have been lost. Okay, so in on-click here, we could say trace ln, my name is, so when we click on it, we're going to ask it to print its name. We could just say this, or we could say this thing. Either way, it's going to turn the string. It's taking a nice long time to fill it out because I'm doing it for the first time. Yeah, okay, fine. Okay, so building it, a happy camper, and we are going to then run it. Okay, here we go. Run. Now, I think it's going to do it when I click on it. Anyone want to say? What is it going to do? So when I click on one of these, it is going to print out its name here. Okay, so it's down in the console area. This gives the output from the model. And when I print on it, it'll say, my name is, and if I go and I stop it here, and I go and I view the console, what you will find is that there are these cases where it was printing the name. There's one of them right now. So my name is root population, and it prints out the characteristics of that person. This is its name. When you render it into a string, this is what it tells. This means I'm the 136th person in the population. It starts at 0 through 135, and these are some of my characteristics. Okay? So my parameters. So each agent knows how to turn itself into a string, to a string. It also knows how to connect itself to others or disconnect from others, and we'll be seeing that tomorrow. to connect up agents. Okay. Now, we noted this morning, you may have remember, actually it was this afternoon, that we could actually get information from or request things from main. I don't know if you remember this. When we came in here, we asked main to remove me from the population. Remember that? We can refer to main, the main associated with me, with a person. And actually, I should have been, or I could have said this, not me, the main associated with me, because there's a reference to main over here. If we scroll up, there's something called main. Do you see that? It's up above here. Every agent points to the thing in which it's embedded. So I, as a person, can refer to myself as this, and I can say, get my main associated with this. And that would be a reference to this instance of main with which I'm associated. There's a main in which I'm circulating that includes the population in which I'm embedded. Okay. You can also call get main to explicitly get it. So we just use this little shortcut called main. Okay. We could have said this dot get underbar main dot remove population alternatively. Okay. So here, get main, or this main thing, this is a reference to main. It refers to main, okay? It kind of points at main. Okay, so ladies and gentlemen, suppose that we have an agent, and we refer to them as A, okay? Now, I wish I could show this to you directly, and I'm tempted to do this in one or more ways, okay? Maybe what we'll do, we're going to do something pretty neat here. Are you folks ready? Do you have AnyLogic with you or no? Some of you do. Some.
Are there any TAs for help?
Yes. Could you get a TA?
They don't have all the features.
Yeah,
Sorry?
the model online is not the same.
Because what you're showing, it only has, are you getting the same thing? It only has the smoking state charts. It doesn't have the heart disease.
Dr. Rosgood, the last term model was uploaded at 249, but we don't have the recent one.
Oh, okay, so it's not an issue, technical issue, it's just that the smoking and heart disease models that are uploaded are not the fully
Wow.
articulated ones.
Okay, so let me just, I see. Yeah, I see what you're saying. Okay, I'll just go upload it now, and then you can grab them. But maybe you could get another TA in here, meanwhile, Tricia. So I'll call this version 5, okay? And I've just saved it now. And I'll upload that here to the site, and you could get version 5, which should have features I'm looking at. So we'll be on the same page. Let's go upload it. There we go. Oops. There we go. Okay, ready? Here we go. File upload. And here we go. Smoking disease. And there it is, version 5. Okay, and it's uploading it here in, okay, it's down there. It's smoking and heart disease 5. Okay? Actually, Kurt, I think you're in higher demand. From the throngs of participants.
Here or elsewhere?
Elsewhere. So if you could get another TA, that would free you up to interact with the projects.
Okay, I was walking around and there wasn't a lot.
Okay.
I'll make another round.
Yeah, could you try to get someone else in here? Maybe bring two TAs in your stead.
Sure.
Okay. Did everyone get that now? Version 5?
I don't see it there.
Yeah.
So you may need to refresh, Kate, like this. There's a little refresh button up here. Do you see that? A little thing that looks like that
Oh, okay.
to refresh the page. You may need to do that. You got it? Okay, ladies and gentlemen. Ladies and gentlemen. Okay. Okay. So tell me when you have that loaded. Great. 2 worthy TAs have arrived. Appreciate it. Okay, if you could sit to the back, we may need some help. Okay? Do you folks have that loaded, or should I give you another few minutes? Who needs a little bit more time? Okay.
So for these connections,
That we're working off of laptops. Okay. If people want to pull up to each other so they can use their own models, that would be good. Use each other's, look over each other's shoulders. Okay. Okay, ladies and gentlemen, were you able to get it? Okay. So let's do the following. We're going to add to each person. This will presage tomorrow our treatment of networks, but we're going to add to each person some network connections, okay? Is that okay? We're going to do this in two ways. The first thing is two-person add, ladies and gentlemen, a thing called mother. That's going to refer to their mother, okay? Okay with that? Arash? We should make sure that the van comes at 6:30 today. Remember that? Yeah. Okay. So what type do you think mother will be? Do you think it's a double, an int, a boolean, a string, a date? What sort of type do you think it might be? Yeah, and a person. Do you see that's an option? Do you see that's an option here? Mother is of type person. Do you see that? See or not? Okay, good. Good. Okay. So this is a reference to a person. Its default value we'll say is, if no one else specifies it, well, we can leave that blank, but we'll make it null. Meaning it doesn't refer to anyone. Okay? Now, ladies and gentlemen, who is it, if we have a parameter in a person, who is it that specifies what to use for that parameter? If it's in a person, what specifies what values to use? Well, whatever creates the person. Where is the person created in this model? There's two places. In the population is one in main. So here we have mother here. And that's going to be the initial population, the population of people who start in the model. And I'm going to leave it null. I don't know what it's going to be. For the people who are born, and for immigrants is another place, right? For immigrants, they come in and they need a mother too. But we don't know who their mother is. They're coming from outside, so we'll give null as well, okay? So it's looking for a mother now. So we're going to give it null as the value of the mother because we don't know who their mother is. When will we know who the mother is? When they are born in the model. Then we'll know who the mother is. Where does birth occur in this model? Does anyone remember? Ken. Just put it there? Because we're saying immigrants. I just typed it. Because I'm saying immigrants, we don't know who their mother is. And we need it. If we didn't have that, it'll complain. It'll say, I need to know who the mother is, and to do this. It'll say, look, I can't call add population because you haven't provided to me an assumption for mother. Okay? But that's not the only place in the model.
How do we know, this is probably, do we know it's looking for birth date and then mother?
Exactly. This is what we do, Cheryl. When you see add population, you do control space, and you see it'll say birth time and then mother.
Yeah, I knew it was there. Thank you.
Yep. So gentlemen.
That's because it's listed under population properties. It says birth time and then it says mother.
Yeah.
So it's pulling it from there.
It's pulling it from the, both are pulling it from the list in the agent. So if you went to person, you'd see that that it has certain parameters, and it actually depends on the order of the parameters, but you can reorder them, the order with which they're added, but you can reorder them. So I'll see if I could show that to you, Kate. So the key place where we'd specify the mother as being non-null is where? The key place is when a baby is born. We know who the mother is. Who is the mother of this baby that's being born? Whose child is this? Who's the baby's mother here? This is the baby's mother. It's the current person is the baby's mother. So when we add them to the population, this is their birth time, and their mother is the woman who's giving birth, who's undergoing the delivery. And so that's this. That's me. This is a reference to me. Okay? Okay, now, what did I do? I did a couple things here. Firstly, for person, I added in a mother as a parameter. I made it type person, and I gave it a value of null. Second of all, I went and there were 3 places I needed to specify the value of mother. One of the places was in population. I needed to say what to assume there. Secondly, when the people got added to the model using add population, that occurred in immigration event under add population in the immigration event. And thirdly, when someone gave birth in the model, I specified who the mother was here. Does that make sense? So ladies and gentlemen, let's go run this model and see what. So what we're going to do is we're going to run it, and for these people in the model right now, whose mother do you think by and large? Well, for most of them, it won't know who their mother is. See that? Because the mother is null. Null means there's no particular person that it points to. So it's a kind of a placeholder, meaning there's no mother specified. It's kind of like NA in a database, in a data set. So here's mother. All people have unknown mothers. But let's run the model further, and let's run it here. Okay, so here we have it. If we go down now, we'll find that most people have mothers that are specified. Not all, but if we go to the later parts of the population, let's say population 500, we're going to probably see quite a few have mothers. This is a person who has a mother. This person in the population is population member 501. Their mother is number 253. Okay? This is a population without a mother that's living. Here's one person 503. Their mother is number 2 is person 226 in the population. Okay? So these mothers are specified. Are you seeing that? That sort of thing? Okay, ladies and gentlemen. Next. Now I want to, when we click on the person, I want to print out the mother's name. I want to print out the mother as well. So we're going to say my name is such and such, and my mother's name is such and such. My mother's name is... And how am I going to say that, ladies and gentlemen? How am I going to write down a formula that will give me my mother's name? What would I say? If I want to have a reference to my mother, what do I give? This dot mother. And then, given that reference to my mother, I can ask dot toString to turn it into a string. Okay? This is me. the mother is my mother, and then I can ask the mother her name, toString. So ladies and gentlemen, when we have a reference to an agent, call it A, we can ask it, hey, give me another connected agent, and then we can ask for its name, okay? Or I could ask for my mother's mother. Or maybe I could ask for my mother's children. I could have the mother keep track of her children and ask for each of them. Okay, so if I were to run this, here we go. I'm going to run this out to the end. I'm going to run it, and here it is running, and okay, I'm going to pause, and now I'm going to click and click on some of these. Oh, it didn't have a mother. Okay, so null pointer exception. It says, okay, it tried to do this. If we click on this, it'll point us to the place where basically it was trying to get information on the mother. My mother's name is such and such. We chose someone, ladies and gentlemen, who didn't have a mother. Okay, so we can ask when we something to print out the name of the mother, but if there's no mother present, it will be very unhappy. It won't know how to print it out. So here we have to sometimes be careful that when we have a reference, sometimes the reference won't in fact be complete. It doesn't point to anyone. So if we have a reference, we can ask that reference to do things. We can ask this dot, give me your mother. And if we have a reference to the mother, then we can ask it to turn this into a string. But it's possible that we ask for the mother of me, it won't actually refer to someone. Okay, so here, ladies and gentlemen, I'll come back to this thing, that we can have a reference to a variable, okay? And this reference, when we have a reference to a person, it'll point to a particular person. In this case, this refers to me. This dot mother refers to my mother, if indeed one exists. Otherwise, it's null. And so for myself, I might have certain properties, and then I might have a mother that has other particular properties. Okay, so for example, I might have a reference to a mother, and she might have reference to her children, and then each of them might have reference to main. Here, okay. So we have these kind of objects, and they know about each other. Each of them has a mother. So let's see how this can be extended a little bit, and this will be a bit of a preview for you folks for tomorrow. Ladies and gentlemen, what I'm going to do now is we are going to put into this model a situation where we're going to have people connected to each other. Okay? They're going to be connected with each other in networks. Okay? So here, what I'd like to do is to go to person, and if you look in person, they will have a set of connections here. Do you see that? It's kind of further up. And we're going to set their connections through our actions now. In order to do that, we're going to go to main, and in main, we're going to go down in the properties of main till we get to space and network. And we're going to choose a certain type of network, which will be a distance-based network with a connection range, ladies and gentlemen, of 50. Okay? Connection range of 50. That's the default. Do you see where that is in main? Next, we're going to go to person. We're going to go to their connections. And under animation, we're going to choose draw line connecting agents. Do you see that? Okay. So I'd like you to check it. Okay? Okay. Okay, ladies and gentlemen. Great. So, here we go. Okay. So, now I'd like you to run the model. You'll notice people are now connected together. Do you see that? In networks. Okay, so what we're going to do now, we have people connected to people nearby them. In other words, if they are within if any two people are within a distance of 50 from each other, it'll connect them. Otherwise, it won't. So,
Does that automatically update?
that's a very good question. It does not. So as people are born, we can make it update, and in fact, we're going to do that right now. Where do people come into the model? Can you tell me two places? Birth and immigration. So, where does birth take place in the model? Takes place in person under this delivery. Do you remember that? Do you remember that? In person. So we're going to go there, and when we add the baby into the population, we're going to say main dot apply network. Okay? Did you get that? Main dot apply network. This is at this delivery point. Do you see that? And we're going to do exactly the same thing when people get immigrated to the model. So under that immigration event, we're going to say main dot apply network after they're added to the population. Are we okay with this? We have to have it recompute the network. Can we do this? So where does immigration occur in the model? Where does that live? Is it in person? It's in main. Because if there's an existing person in the model, it's not about someone already in the model. It's about something about the environment. So that's why we're putting it in immigration. So we can, in main. So if we go up to main, there's an immigration event, and we can do apply network there. Okay? Sorry, no, you don't need to say. In fact, you shouldn't say main dot. It's a bad thing. We should say this dot apply network because we're in main. Now we should build the model. By the way, do we need a semicolon after this in general? Yes, we're telling it, do this thing, apply the network. Basically, it says refigure out the network now that there's a new person. Can we try it? Ladies and gentlemen? So now what do you think is going to happen? Put it in birth, apply network, and we put it under the immigration event. Okay? You hear people come in, and you can see, Kate, they're being added. Do you see them? Do you see the network being built up? Okay. So, ladies and gentlemen, this main, those are references to persons or to main. And if I say this in main, it's a reference to main. If I say this in person, it's a reference to person. Okay, now, yes. Oh, when they're dying. It actually removes, you'll notice when someone dies, it's actually removing any networks associated with them. It's a good question, and there may be cases where that is needed, but for the most part, it seems to take care of it fine. Okay? That's my recollection. Okay. Ladies and gentlemen, so now because sometimes there's a mother, sometimes not, I'd like to go back to person, and when we click on their little oval, I'd like to go through each of their connections and report that person's number of connections. Okay, or sorry, that person's each of their connections and report that person's name. So so we're going to say my name is such and such, and then we're going to say I am connected to the following people. Okay? And then we're going to go through each of the people around them. We're going to go get a reference to each of those people and print out their name. So this is how you do that. There's several ways to do this in AnyLogic and in Java. I'll do it this way. For person P in this dot get connections, for each of the people to whom I'm connected, I'll put it up on the big screen here in just a second. Trace ln p dot toString. So this is what it's going to look like, and there we go. Yeah.
Why is that not included with the trace LN?
So this loop is occurring for each person. It's going to go through each person's population and call them, or so for each of this person's connections, I'm going to go through each of them and call it P, and then I'm going to print out the name of that person, the toString of that person. Now, in fact, I could just say P and it will automatically convert it to a string, but I'm being a little bit pedantic here. Each of these is going to be a reference to a particular person, one of my connections. Okay? I'm doing this partly because Marie is interested in networks, and I want to show how you can handle these things. Okay? So you should be able to build this. So this, what we have here is a reference to a person, and they have references to each of these people, each of the people to whom they're connected. This is their get connected agent 0, get connected agent 1, get connected agent 2, and we're going through each of these and printing their name. This person also has a reference to main. Oh, okay, so it's an unhappy camper. Look at this. It's saying I can't. Oh yeah. Oh okay. Yeah. Okay. Fine. Okay, ladies and gentlemen, I forgot to do one thing. This is going to spare you a lot of grief. This is a newer feature of AnyLogic, as of version 7, I think. Okay, ladies and gentlemen, for person, go to connections, and we need to declare in connections, and this gets to something that I was telling Betsy before. In connections, in person, we're going to go up here and choose agent type, and we're going to say person. That means this person is connected to another person. This connection is to a person, not just to an arbitrary agent, but to a connection. For example, if they were maybe connected to their dog and to other people, might have it just generically connected to agent, because there's both types of agents. But here we're going to have it connected to person, these connections. Okay, ladies and gentlemen. Okay, and is it a happy camper here? Hold on for just a second. Oh, okay, still having, oh gosh, okay, sorry, I need to think for a moment. Sorry, just a second. I know there's a way to do it with this. Okay. Yeah. Dot connections dot get. Okay. Sorry, folks. Okay. Get connections. Okay. This is unfortunately more painful than I thought it would be here. Okay, now it works fine. Okay, sorry, I had to correct one thing here. So you need to go to this connections, and you need to set it to indeed be agent type person, and this is how you loop over it. I had this like that, and it should be this. Okay. You asked for my connections. Okay, get the connections through that. Okay. Sorry about that. I'm just going to confirm this here. Okay, here we go. So now we can click on this, and now I say I'm connected with the following people, and it will print out each of the people to whom I'm connected. I could click on this. Yeah. Okay, help. Okay. So ladies and gentlemen, so now we can loop through for each person on whom we're connecting. It's going to go through each of their connections and report them. Okay? So, Aiden, are you looking for this? Remember, you need to set the connections to be to people, to person. Okay, who needs help? Okay, sorry? Yeah.
On yours, it says for state parking, it has some checkboxes for smoking states, working states, and drinking. Yours is state parking state check. Is that, I think I probably left in and needed to.
This is actually, and this is related to something I was telling Winchell about. Winchell? You notice with these connections, you can route these messages to one or more state charts. Oh. And so two state charts could receive the same message, for example. So this is basically, let's suppose an HIV infection message came in. You might route that to an HIV state chart, whereas a Hep C one, you might be interested in going to Hep C. This tells it basically, where do you want to take, when incoming messages come, where do you want to route them? So maybe I have certain types of connections which can only transmit certain types of pathogens, so I'd want to route those to certain state charts while others go to other state charts. It turns out we can have several types of connections. Some might be social connections, some might be connections with intravenous drug use, some might be sexual connections, and I could have different sets of connections for each to capture different networks in which I'm associated. And each of those networks might have a subset of state charts to which they should be routed. Now, if you're asking why, and in yours are certain ones checked versus mine, I can't tell you, but it's not going to be relevant at this point.
Also, if you have them, like if you don't have them checked there,
Yeah.
Does it matter, or is it like could you have them all checked and then if there's nothing written in the state charts or otherwise to tell them to?
Yeah, right now we're not sending any messages yet. Tomorrow it will matter, but right now we're not sending messages. Okay? So, ladies and gentlemen, we should be able to run the model, and we should be able to click on particular individuals. Okay? And when we run those individuals here, we should be able to have it print out the people to whom they're connected. Note that this will work even if I'm pausing the model, it will still work. Okay? So like this person is only connected with one other person, so it's just printing it out here. By contrast, this person is connected with 3 people, so it's going to print out 3. This person is connected with none, so it prints out nothing. So ladies and gentlemen, yes?
You're clicking on a person and it gives us some problem like
Winchell, could you take a look at this? What problem does it give you?
null pointer section. So
For what? Do you have this dot mother still? Winchell, this is the code.
you have the model or
Yeah, you should get rid of mother.
The mother thing,
Yeah. So this is the code here. So it should just say my name is such and such. I'm connected to the following people, and then it goes through each person and to whom I'm connected, and it turns it into a string. Okay. Okay. Ladies and gentlemen, is that working for you? Okay. Okay. So the point here is these are references. We have a reference to this. It refers to a person who has these connections. And so I, as a person, have certain connections up here. I'm a person, I have certain connections. We're going through those connections, sort of each of those connections here. And for each of those connections, we get a reference for that connection. We'll call them P. We have a reference to them, and we say print out your name. Okay? Does that make sense? Okay. Alternatively, I could say here, for example, alternatively, ladies and gentlemen, I could say here, okay, for each of those connections, I want, so what's, is there a problem still?
it doesn't show up. It says
Okay, is Winchell still here? So okay. So if TraceLN isn't printing, is the console window printing?
Yeah.
Is it printing other things?
yeah.
Okay. The question is it receiving the click event? So let's develop a hypothesis. The hypothesis it's receiving the click event, but it's not somehow printing. So in the click event, you could get it to print out 1 divided by 0 and see if it dies when you click on it. Okay, that would be one hypothesis to advance, to investigate. Okay, okay. Okay, so ladies and gentlemen, what we're going to do now is we're going to talk a little bit about what this involves, okay? So we talked about how we can get main. If I have a reference to an agent, I could ask to get its main by calling get main on it, or a dot main should work as well, I believe. Let's consider that we have two references, one to one agent, one to another agent. In principle, those could refer to the same agent. In principle, for example, this get connections mother, or get connected agent 0 mother could refer to the same person as my mother. So we could have two different ways of getting to the same mother, for example. So I might have a sibling, and both of us share the same mother, right? So we might have that. Or I might have two variables, each referring to a person that happen to refer to the same mother. Now, if we have a variable and we assign from one to the other, both will then point to the same element. So let's try to show this. If we had this code here and we were to stop this, okay, we could, within the context of this model here, go do something like this. So when you click on this, okay, here, I'm going to go through each person to whom I'm connected, and I'm printing out their name. I could alternatively, within this loop, for each of these people, I could ask, for example, for their connections. And I might find that several of their connections are shared, so they refer to the same people here. Okay, here I'm printing out names, and if I loop through and printed out their connections, I might find there's a lot of commonality here. Here I might choose, for example, I might choose to give a short name to each of these called P. This is called this is a short variable referring to each of these people, and by looping through each of them, I give each of them the name P in turn. We can also create a variable that represents kind of a short name for something. So I can say, for example, person mother equals this dot mother. Now that is just a brief name for, it's a reference that's the same as whatever this dot mother is. So if this dot mother is null, this mother will be null. If this dot mother refers to someone, mother will refer to someone. And by giving names to things, this is called a variable. We're just giving a short name to this quantity. Okay, now when we have two variables, A and B, for example, they might refer to the same underlying object. Both of them might refer to the same person. Say you have a sibling, their mother is the same as your mother, and if one of them, donates something to your mother, to their mother, then you've received it as well, because your mother is the same as their mother. So if we have two references to the same person here, and we set some property through one of them, this other one will see that change as well. So maybe a value of a certain variable in this agent to which they point is 4, and when one of them sets it to 3, the other will see that change. Okay? Now, we're going to come back to this notion again, but there's a thing called an array, and in fact, we are iterating through here a sort of array of getting the connections for each one. By calling get connections, we get a collection, and we're iterating through each member of the collection, calling it P in turn. We're going through each one, and we're reporting on their characteristics. So we could, for example, ask their name. We could also print out, besides their name, we could print out, we could say has, and we could ask how many connections does that person have? P dot get connections number. Okay? We could ask how many connections do they have. So here, and I will shorten this up so you can see it. I'm gonna put it up on the big screen so you can see the essential pieces. Instead of just saying p.toString, I'm gonna say p.toString has a certain number of connections. Okay? And now, for this person P, I've asked how many connections do they have. This person P is a reference to a person whose name we're asking for, and then we're asking for their connections number. So if we have a reference to something, if we're referring to a given object, we can use that reference to ask for information. We can ask for its mother, we could ask what's its name, we can ask for how many connections does it have. And that's what we're doing with this all the time. We're asking for things about me. Sometimes we do it with main. We ask main dot remove population, and we tell it who to remove from the population. So if we were to run this now, and we were to click on a person, now it was reporting. And I'm going to pause it. We can pause it, and we click. We'll see it more clearly. Okay, I'm connected to the following people. Oh, I should have said has 6 connections. Okay, has 6 connections. So I'm reporting the number of connections associated with each of my neighbors. So, in short, this is a reference to a person, and using that reference, we can ask for information about it, and we could report that information. Yes, Betsy.
How come in that statement it was p.get connections number?
Yeah.
Because above this connections dot.
Yeah. Because I want to find out how many connections that person who's a neighbor of mine has. This P is referring to my neighbor, and I want to know how many connections do they have. Does that make sense?
Yeah, just trying to think in terms of this object.
Yeah.
Orientation.
Yeah. So
When that statement, the p colon
this is going through each person to whom I'm connected, and I'm giving them the name P. So they're each of my friends, and I'm saying for this friend, what's their name, and how many neighbors do they have? How many connections do they have? Then I'm going on to the next friend and saying, what's their name and how many neighbors do they have? Does that make sense?
I think so.
Okay. Okay. So, ladies and gentlemen, here, if we were to look at this a little bit more closely, what we'll find is that when we have code like this, we often will want to use clear names. Like right now it just says P. I could have called it person. That was just a different name I could have used. I could have said for each of my neighbors. Maybe that's the best one. I'll leave out the U here again. And I'll say for them, what's their name, and then how many connections do they have, and I'll report it here. Okay. Okay. So I've just changed it to this. All I've done is change the name of the variable. So much of our work in AnyLogic involves getting references to objects. This, for example, or main, or this dot get connected agent, and get connected agent of 1, and then using that to ask for information. In this case, we're iterating over each neighbor of ours, and we're printing out its name and the number of connections that it has. This thing called neighbor is a reference to a different person. It's a reference to one of my friends, whereas this is a reference to me.
So you can define
Yes, this is a definition of it. It's saying, for each person in my connections, call them neighbor. That's how to read that. It's saying, for each person neighbor in my connections. That's how we'd normally say it. But each of them is being called, each of the person, this is a collection, and each of those people in that collection is being called neighbor.
Oh, okay, you just said.
In turn. Just like item, do you remember in statistics we called them item? I just changed its name to neighbor because it's clearer. Because Betsy recently asked, what's the relationship between P and this? And I just wanted to make it clear. This is a neighbor of mine. Or we could have called it friend. Each of my friends. So each of my friends has a name. Each of my friends has a number of connections. That would be another way to put it. The point is, this is a reference to some person who's among my connections. And for each of them, I'm going to print out their name and the number of connections that they have. You got that? So that's what this is doing. That's what its job is. And ladies and gentlemen, when we write this is just a reference as well. These are references to each of my friends. I'm successively referring, to so maybe this is who I am pointing to. This points to me. And then for each of my friends, I'm referring to them as friend in turn, and I'm printing out their name and their number of connections, their name and their number of connections, their name and their number of connections in turn. Does that make sense? That's exactly what this code is doing. It's through each of my connections, it's printing out their name and the number of their friends. That's what this get connections number is. It's the number of their friends. So in each of these is a reference to an object. It's a reference to an object. Remember, I started this lecture talking about classes like a mold, and from that we instantiate, we create instances called objects, and each particular person is an instance of capital P person. And then here, often we'll gather references to the people. Here I'm gathering some references to my connections. I'm going through each of them, calling them friend, and I'm printing out their name and their connections number. And that's very similar, ladies and gentlemen, to what's going on here in population with statistics, where we are in statistics going through each person in the population, getting a reference to that person called main, and then we are asking, are they in this state current smoker? Does that make sense? So to finalize things, and the bus will be here in just a minute, if we were to go back to person here, I could go here and I could report whether or not that they are a smoker, right? I could say, I could say this. I could say, and I'm going to put curly brackets, meaning I'm going to have more than one statement here, more than one command, and I'm going to say, if friend dot in state, and I could say person dot current smoker, I will say trace ln, is a smoker. Or I'll say friend, I'll give their name, is a smoker. So I'll report out as I'm going through each of them, are they a smoker or not? Okay? So that's what that is. And there we go. For each, so I put these curly braces in there, and for each of them, I am asking, is the friend in a certain state, namely the state which says they're a smoker, and if so, I will print out this information. Alternatively, I could have kept track of the number of them. This is very similar to what we did here when we counted the number of smokers. We used the exact same approach where we asked for each item, are they in the state person.current smoker? Okay? And we're asking if they are a smoker. And then we're going to have to break here because the bus will be here momentarily. So, TAs, could you help here? Just clean up any final problems. Who needs help here? Anyone need help? Help here?
Actually, it's more, I don't know, like the model of the individual or
Okay, ladies and gentlemen. And Winchell is there too, so. Here we go. If I click now, we can pause the model, click. Okay, we can click here and you'll notice some of them now say is a smoker here after them. If you scroll over here, they'll say is a smoker. Okay? Over here. So-and-so is a smoker. So-and-so is a smoker. Now it prints out whether or not they're smokers. Okay? As a result of our change, as a result of this, when we find a friend who's a smoker, we'll print that information out. We'll say so-and-so is a smoker. We'll report the number of connections of each friend. For the friends that are smokers, we'll report that explicitly. So this is how we refer to particular people, determine their characteristics, can take actions, could write them to a database, could write them to a file, record all the people who are smokers, what have you. Very common need. We're working in short with classes like person, with instances or objects like particular people, and with references to them like this one called friend. Okay, that's all we have time for. You folks have got to go catch the bus. But tomorrow we'll be talking more about these sort of statements in Java and expressions, these sort of formulas in Java we use to build up these bits of code that we're putting throughout our models. Okay? But you better get down for the bus before it's missed. Okay? It's going to leave it. Sorry? I'll upload it right now. It'll be called version 6. Okay? Version 6. Okay? Yeah, so if we wanted to connect, and a final thing here, if we wanted to connect each person to their mother, at the point of delivery, what you could do is you could say this is the mother, dot connect to, and what you'd need to do is you want to connect them to a baby. The problem is you don't have a name for the baby, so you need to say person baby, give a nice little variable for it. So it turns out add population returns a person, okay? So it actually, when you call add population, it actually adds them to the population, but it also returns a reference to that person. And that person is going to be the baby, person added. And then you could say this person, the mother, connects to the baby, okay? And that will guarantee that baby gets connected to. And what's going to happen if you do that is that there's going to be some babies who are connected longer distance, okay? Now the problem with this is that in this model is that we're applying the network that's distance based on an ongoing basis, and that may change those connections because it won't allow for a long distance connection. That's the problem. So if you're and that's the problem with doing this apply network here, with this apply network, okay? Now, if you left out this apply network from here and you left it out from main when immigration occurs, if you got rid of this, apply network. Now you're going to be adding in. You're going to see the connections between babies. It's just if you're saying we want a distance-based network, AnyLogic's going to be working to try to make that happen. Whenever you say apply network, here you could start to see the babies being connected to their mothers. See that? And if you're trying to mix it with distance-based networks, the best thing to do is to situate the baby within a guaranteed distance of the mother so that they will automatically be connected by virtue of the distance-based network.
The other way to do it is to create another network.
Yeah, you can have you could have a family network and a social network. And I referred to that earlier when saying that you could have multiple. Remember when I said you could have multiple networks, an IDU network for intravenous drug use, a network for social connections, a network for sexual connections. Those could be different networks, and you could have them governed by different rules, essentially. So one would be connected based on certain criteria, another one based on others. However, Scott, with I think when you apply network, that's applying to the default network?
So I was going to say yes.
That's what my understanding is too.
You might be able to call apply network on the connection link.
Exactly.
I don't know if you can.
I don't know that if you can. It's an interesting question. Let's just go from that. Okay, so go into person. Here we go. Okay. This dot connections dot apply. No.
Okay.
No. So it's only, and that makes sense because only the default one probably is associated with the built-in network types.
Correct. Yeah.
Yeah. Okay. So if you want to see it with two different networks, one thing you could do is this. Ooh, that would be sweet.
What?
Oh, that would be sweet. Watch this. Okay, here we go. Here we go. Here's the regular connections. And I'm going to add in a new type of network, which is going to be my family network. Family network, okay? That's going to be my family network. And that one is going to have a line between agents that's going to be of a different color. That's going to be red to indicate that it's a more critical network, okay? It's going to be my sort of social network and my family network, okay? Now, ladies and gentlemen, now one thing we're going to do then is at the time that the baby is added, okay, we're going to connect to our family network, okay? Family network dot connect to the baby, okay? And we will apply the network because the baby may be physically close to others.
Correct.
To which it needs to be connected. And similarly in Maine, and it may be that you want to locate the baby near the mother for other reasons, but here in Maine, where immigration occurs, we're going to still have it apply network, okay? So now we're going to have some family connections and some social connections. And what do you think will happen when we run this? It's going to be a pretty sight, well, so to speak. It's going to be an interesting sight anyway. Mm-hmm. You're going to have long distance red lines, and you're going to have short distance black lines, right? So there's a connection between a baby and its mother. There's another one over there between a baby and its mother. But fundamentally, there's going to be these connections that are familial layered atop, and which can be long distance, and then these kind of very localized connections, which might represent proximity of individuals that might be more localized. So here we have a layering of two networks in a way that's visually distinct. And you can even set, declaratively, you can set the properties of those network connections here.
There's another version, I mean,
Okay, see these family networks? You could set it, for example, to have a different thickness of agents, or of lines, line width, to make it thicker or whatever, and it would appear visually distinct, okay?
Okay. That was very useful.
One other thing you can do is, the family network's fine. The issue is that it's not very descriptive.
Right,
For example, you can't tell which one's the mother and which one's the child in that relationship without other. So what you can do is you create directional links.
Yeah, directional links.
And then you can also, instead of a connection, you actually have a link called mother. And it's a visual link to that. It's a parameter, it's also a network. So, and it's not huge, I'm sure Dr. Mont's going to say more about it.
Yeah, no, it's true, and particularly if there's a directed relationship. So, so and so is my mother. It's not bidirectional, in the sense that I mean I'm her son, but that's a different type of relationship, and so and maybe that you want two different unidirectional connections rather than one bidirectional connection. Yeah. Anyway, that's one way to do it, and sure, I'll go post that. Okay.